Good morning, everyone, and a very good day to our lecturer, Dr. Evina, and fellow classmates. We are from Group C and would like to present our group project using the working model 2D software, the design and simulation. Before we start, my name is Audrey Adriana Sayo with a metric number of 102452, and these are my team members, Abang Muhammad Amirul, Josephine Tinggang, Luis Miguel, and Eric Lian. To begin, a wheelchair is an important mobility aid for elderly and disabled individuals who have difficulty walking or standing. However, conventional wheelchairs usually provide only basic movement and often lack features such as reclining, adjustable height, and standing support. These limitations can cause discomfort, poor posture, and increased dependence on caregivers. Therefore, our project focuses on designing a multifunctional wheelchair that improves comfort, safety, and user independence. To evaluate the design, mechanical modeling and simulation are carried out using Working Model 2D. This allows us to analyze motion behavior and interactions between mechanical components before physical prototyping, ensuring reliable and efficient performance. This project also supports United Nations Sustainable Development Goal 9, which focuses on industry, innovation, and infrastructure by promoting innovation in healthcare assistive devices through engineering and digital simulation. Next, my teammate will explain the design concept and methodology of the project. Thank you.
In this product overview, the problem solved is that we address the chronic sitting issue, poor circulation, and difficult in daily activities. Second, the purpose of this product is that it will enhance autonomy and comfort for chronic wheelchair user. Last but not least is the innovation for this wheelchair. It can reconfigurable wheelchair with sit, recline, and stand function.
Good day everyone, my name is Josephine Tinggang and today I will be walking you through the methodology and technical design process for our wheelchair project. Our goal was to move beyond a simple concept to a fully realized engineering solution. To achieve this, we follow a structured 9-step workflow that ensure every design decision was backed by user needs and technical analysis. Looking at our process flowchart, we begin with phase 1, which is group discussion where we brainstorm the scope of the project. This leads directly into phase 2, where we identify the core problem and define our specific objective. In phase 3 and 4, we conduct a deep dive into user need. We didn't just want to build a chair, we wanted to build the right chair for them. This involves analyzing requirements and generating multiple concepts before selecting the most viable design. From there, we transition into the technical execution. Phase 5 through 9 represent the core engineering work where we move from paper to AutoCAD modeling and then we perform rigorous engineering analysis and simulation to ensure structural integrity. Finally, we underwent a cycle of optimization to refine the design before reaching our final documentation. Now, let's look at the actual output of that methodology. On this slide, you can see the detailed technical breakdown of the wheelchair. At the top right image shows our dimensional analysis. Every length was calculated to ensure ergonomics, comfort, and balance. You will notice specific callouts for the wheel diameters for the rear and a smaller ratio for the front wheel in order to ensure a low center of gravity and ease of propulsion. We also focus on the length for the mainframe to provide enough stability without sacrificing maneuverability in a tight space. To the bottom right image, the schematic diagram simplifies the assembly into its primary component, which is the handle grip, backrest, armrest pad, seat, frame, and the relationship between the large rear wheel and the smaller front caster. In the top left, we have the orthogonal views. This provides the standard multi-view projection from the top, front and side, which is essential for manufacturing and a spatial understanding. Finally, in the bottom left, we see the simulation model. This stage was crucial. By simulating the wheelchair in a virtual environment, we could visualize how the frame distribute weight and how the wheels interact with the ground. This helped us to confirm that the design is not only aesthetically functional, but also mechanically sound and safe for the end user. So, in summary, this methodology allows us to transition from the broad idea to a precise engineered model. By integrating AutoCAD modeling with simulation and rigorous dimensional planning, we have developed a wheelchair design that is ready for the next stage of prototyping. Now, let's look at the working model 2D simulation. In this video, we test the physical behavior of the design. As you can see, the simulation confirmed that the chair remains stable and balanced while in motion, which proving that our AutoCAD dimension translate perfectly into a functional, safe, and reliable mechanical system.
Good morning and good afternoon. My name is Luis Miguel Medan, matrix number 104797. In this part, we're going to talk about the reclining basic mechanism. The mechanism is a pivot hinge with full range of motion from 0 to 180. The multi-position locking system ensures stability at secure angle. The key lock point for this pivot is that it is 180, which is flat, 90 degree, which is upright, 70, 60, and 45. The benefit of this pivot hinge is that to ensure a posture variation, which can support dynamic sitting position for comfort and health. Second, it can reduce pressure injuries, which can promote circulation and relieve stress on pressure point. Last but not least, it can enhance autonomy, empower user to independently adjust sitting without external. Next, we're gonna talk about the wheelchair frame design. The material we use for this wheelchair frame design is that we use a lightweight composite which made from carbon fiber and advanced alloy. The rationality of using this material is that it has a very high strength to weight ratio, durability, and reduced overall mass. The benefit of using this material is that it is easier proportion, which reduce effort for user, especially on uneven terrain. Second, energy efficiency, optimize transfer of force, minimizing fatigue. Last but not least is the SDG 9 alignment, which support industry, innovation, and infrastructure by integrating advanced material and engineering for sustainable mobility solution. Last, we're gonna talk about the wheel specification, rear wheel diameter, which is 64 cm. The reason why we use this large wheel is that it can reduce rolling resistance and improve propulsion efficiency.
Hello, my name is Eric Lian with metric number 104030, and I will be explaining the design of the multifunctional wheelchair. This wheelchair is designed as a multifunctional system that allows user to sit, recline, and stand in a single device. The reconfigurable design helps chronic wheelchair users change posture independently, reducing circulation issues, pressure sores, and difficulty in daily activities. The next one is real wheel and mechanical design. The wheelchair operates based on the wheel and axle principle, where force applied on the hand rims produce forward motion. The large 64 cm real wheel increase mechanical advantage, reducing the effort required for propulsion and improving energy efficiency. Now for front caster wheel design. The front caster will have a smaller diameter of 24 cm to improve maneuverability and directional control. While they may increase rolling resistance on uneven surface, They are well suited for controlled indoor environment, such as healthcare facilities. For the next one, seat cushion and user comfort. The wheelchair seat use memory foam cushioning to improve comfort and support. Memory foam contours to the body, distribute weight evenly, and help prevent pressure sores during long periods of sitting. The next one, seat to floor height design. The seat to floor height is set at 50.5 centimeters, which is slightly higher than the standard range. This design benefits taller users and makes transfer to bed, tables, or workstation easier while accommodating thicker cushions. For wheelchair handrim design, the handrim are enhanced with high friction coating and ergonomic shapes to improve grip and control. These feeders reduce hand strain, improve propulsion efficiency, and support users with limited dexterity. For footrest inclination design, the footrest is inclined upward at 25 degrees to support proper leg positioning. This reduces lower limb strain, improves blood circulation, and helps distribute the user's weight more evenly across the wheelchair frame. Then, the use of simulation software. Simulation software, specifically WM2D and AutoCAD, was used to evaluate motion behavior, stability, and component interaction. This approach reduces material waste, minimizes design error, and lower development costs. Smart technology and safety feeders. The design also considers the integration of smart safety feeders such as GPK tracking system. These features enhance user safety and support caregivers, especially in healthcare environment. Overall design summary. Overall, this wheelchair design combines mechanical efficiency, ergonomic comfort, and functional adaptability. By integrating innovative materials, efficient design, and modern simulation methods, the project supports sustainable development goal 9 through resilient and inclusive healthcare technology.
As the conclusion, a multifunctional wheelchair was successfully designed and stimulated using engineering principles. The design integrates reclining, standing, and adjustable features to improve comfort and independence. Ergonomic elements such as seat height, cushioning, hand handing grip, footrest angle, and wheel size enhance user safety and mobility. Memory foam cushioning helps reduce pressure sore and improve long-term sitting comfort. AutoCAD and Working Model 2D were used to analyze motion, stability, and functionality. The project support SDG 9 industry, innovation, and infrastructure by promoting innovation in healthcare equipment.